Hello guys, Winston here. I goofed. In my previous video I made an Eddie Kramer style stock fixture for Pavel the PocketNC and it totally doesn't work. Aside from the limited rigidity, as some of you have pointed out, because of the material margin required to use it, I would immediately exceed Pavel's y-axis travel limit if I tried to use it. A quick visual inspection would have told me that, but I had neglected to do that, so instead I'm back at square one. What I need is an even lower profile way to get bar stock on Pavel. Going through the B-table and using the ER40 collet is theoretically possible, and I've done something like that, as has Johnny Q90, but with a piece of stock this wide, I'm worried that I won't have enough holding torque on that interface. So I need a fixture plate that holds my stock at points that are as widely spaced as possible. So here's what I came up with, an adapter that bolts to the B-table that the stock itself also bolts to. Super simple, lower profile than just about anything short of a dovetail work holding solution, which doesn't exist for the PocketNC anyways. I drew up this idea in Fusion and made some toolpaths for it, face, bore holes, profile, really easy using my usual Nomad recipes. And if you don't know what they are, I'll link to a video on the Carbide 3D channel where I have them laid out. One small complication was that my holes for mounting my stock needed to be counterbored from the other side, so I had to flip my adapter over and re-index it. To do that, I machined some locating features to align my adapter. Double-sided tape was used to hold down my workpiece since this counterbore would be a relatively gentle operation. And then I got home and did a test fit on Pavel. Things were looking really good, but before I could load anything onto that fixture plate, I needed to prepare my stock. This fixture requires material that's flat on one side and has tapped holes drilled in a rectangular pattern. Doing that by hand without a drill press was dicey at best, so I knew I'd have to call upon my Shapeoko for this bit of stock prep. First, I flattened the ends of my stock using a 1/4-inch cutter. Next, I had to figure out how to drill the holes. The Shapeoko doesn't have enough clearance to do this in a straightforward way, so I had to get creative. Even though you can only fit 3 inches and change under the Shapeoko's gantry, you can get away with a much taller piece of stock if the gantry never has to move over it. In that case, you only need to clear the router, and if you move the router up, well, then you can get a much more respectable 4 or 5 inches to work with. I'm using a boring operation with a shallow pitch in the hopes that smaller chips will be easier to clear and an 1/8-inch single flute end mill to minimize the chances of chips clogging the flutes. Total depth of cut is 1/2 inch, which brings the collet down a little too close for air blast to be effective. Later, I would realize that I really only needed about 3/8 of an inch of hole here, but without that knowledge I ended up stalling the spindle once. Once I had these holes machined, I tapped them using a bottoming tap set for maximum threads in a blind hole. My stock fit on the adapter with some 1/4-20 cap screws, and the adapter fit on the machine. Things were looking good, but then I realized that I was still cutting things uncomfortably close from a clearance perspective. Let me sketch out some construction planes for you. These represent my y-axis bounds. On the y-axis, you can't exceed 2.55 inches above the center of rotation. That is a soft limit that cannot be overridden. On the bottom, the spindle is limited by the ER11 collet nut, which is a few thou under 3/4 of an inch in diameter, so 3/8 of an inch above the top face of my fixture plate is as low as I can cut. The space between these two planes is not only where my part has to fit, but also my toolpaths. So my part has to fit between these planes with at least 1 cutter radius of margin all around. Machining my part would be impossible within these constraints. I needed more clearance. Reducing the thickness of the fixture plate was the only way to do this. Had I been at the Carbide 3D shop where I currently keep my Nomad, I would have modified my fixture plate there, but the day I realized my screw-up was on a Friday and I really wanted to start the 5-axis part of my project over the weekend. I'd have to do all my rework on the PocketNC. I made some modifications to the model and split up my machining into 2 parts. I would be having to machine down almost every part of my fixture, including where the bolts sat, but I also needed at least 2 bolts in place at any given time to keep the piece from flying off the PocketNC, so that would require playing musical chairs with my bolts. The nose to table of the PocketNC is actually quite large. It's extremely difficult to machine down to the surface of the B-table from a perpendicular orientation, even with an extended length tool holder. I used a Datron 3mm single flute because of its 6mm shank. That would give me maximum rigidity at the insane reach needed to modify the fixture plate. However, because of the ridiculous looking tool setup and the rigidity of my rotary axes on the Gen 1 V2, I really couldn't push my feeds and speeds any faster than I could on the Nomad. Pavel might have more power, but he can't put it down. Newer revisions of the V2 machine should fare better. Milling away the material between my primary hold-down bolts took a fair amount of time. If I could do it all again, given what I know now, I would actually have modeled this fixture plate without any material there at all. Then I could just cut it away with a contour op and save a lot of time. Inefficiencies aside, what I ended up with is what I believe to be the lowest profile fixturing solution practically possible for large stock on the PocketNC. This fixture was the key breakthrough I needed in order to proceed with Project Malice, a collaboration I'm doing with another maker in Canada. But that's a project for another video. In the meantime, I want to thank you all very much for watching, and I'll be back soon with more CNC projects and 5-axis mayhem.